6 feet, 6 feet, 6 feet, 6 feet. This is feet, 3 feet. Total here of 9 feet. The last thing is we need to give them name A, B, C, D, E, F, G, H, I, J, K, L. L here, L is a ruler. A is a pen. This is called symmetrical shape, symmetrical load. So, we have here reaction. I would like you to give me what is AX, guys? 0. Agree? Everybody? Yes. AY, LY, do you agree on this?
Yes.
Do you agree on this? Symmetrical load, symmetrical shape is going to give you equal reactions and they are the same magnitude. You don't believe, or you don't want to do it like this, you don't want to save time, that's okay. Sum of the moment at A equals 0. Put your finger here. 400 times 6 is negative. This one. 400 times 12. This one. Negative. 400 times 18. Negative is this one. 400 times 24. Negative is this one. 400 times 30.
Also negative.
Did we miss something?
This is 200.
400 times 6, 400 times
200
1.
doesn't.
The middle 400
The
times
one at L
What this one
does.
does though. Yeah.
18. Then 400, 400. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative. The 200
Positive or negative. Times 56.
times 36 is negative. Positive Ly times 36 equals 0. Put it in your calculator and give me what is Ly. Put it in your calculator and give me what is Ly.
1200.
1200.
Anybody,
And I
anybody
took-
else agree with that?
Without my calculator, I agree with it.
Okay, that's why I want you to put in your calculator and you will get 1200 for sure. Because this is, look, 200 here, 200 here, 400 here, 400
Right,
here,
it's
400 here, 400 here, 400 in the middle. That means the reaction should be the same because
Just add up all the
the
forces.
distances, this is why I put the 6's up. In your book, put it the 3 6's up, the 3 6's down. But when I look at it like this, distances are the same, amount are the same, it's making it balanced. Each one should carry the same, just like a car or four-wheel, the load is evenly around the center of gravity. Each wheel will take the same load. However, if you come to the and put the load here more, this wheel is going to be 0. Agree? So this is exactly, you put it evenly between them, same amount. So immediately I look, 200, 400, 400, and 200, this is the reaction in here. 200, 400, 400, and half of this is the reaction in there, done deal. Or add them divided by 2, yes.
So, but if it wasn't symmetrical, then we have to do the moments.
Yes, if it is not symmetrical, or one of these loads are different amount, you should need to do the moment in order to find the amount. Is this okay for everybody what we did so far here? Let's start with joint A and move from there to see what we can do. A, joint A, it has this one here, it has this one here, it has this one here, this angle here, let's call it alpha. What is alpha? Tangent -1.
6 over 3.
9
3 over 6.
over, this is 9, over 18.
26.6.
Any different?
Another 26.6, correct? Look with me. This one is AB. This one is AC. Where is AB should be? Pointing up or down?
Down.
Down, to make equilibrium with the 1200.
We have the 200 also.
Yes, we will put it. The other one is going to, this is going to put this way, so the other one should be in this way.
Right, yeah.
Now, this is just, I could be wrong. Agree? If you don't want to just go assign any two arrows in any direction, what we are missing in here? The force. We have 200 force here. Because this paper with hole supposed to look, what do I see around A in here? I see this force, I need it there. I see this element, I need it there. I see this element, I need it there. I see this force here, I need it there. This is 0, I don't need to put it. Start with sum of forces on Y equals 0. 200 is negative, positive 1200, negative AB sine alpha equals 0. AB 1000 over sine 26, what is that?
1,990 something. Well, I guess it would be
2230, correct?
Yeah, 2223.
Yeah.
yeah, 2233.
I'm not smart, I just read it from here.
Yeah.
This is 100, 223, this is 1000, 2230. Correct? Or use your calculator. Let's look at this, the other one, sum of forces on X. Equals 0. AB cosine alpha is negative. AC is positive, equals 0, or AC equal 1990. Put in your calculator, it could be a couple thousand. Put in your calculator. And sometimes I make mistakes by
1994.
1994. Let's come here and see what we got. We got AB, this one here, and AC is this one here. If you don't want to put values here, that's okay, but you should put the values to the next one. This one here is this way, and AB 2230. This one is in this direction. 1994. What about this? Which one is the compression? Which one?
Tension and AC.
Yeah,
So this one here,
that's compression.
this one here,
Tension.
tension. Which joint to move to now? If you go
C.
to B, 1, 2, 3 unknowns,
See,
so I need to go to C.
We end up with another.
Joint C, CA equal 1994. This one should be in this direction, CE. And this one doesn't matter which direction, it's called CB. So this is, by the way, each one of these joints needs a single free body diagram. Without a free body diagram, your equation will be cut to half, especially on the test. Each one, do you see me? For each one, I draw a free body diagram. And this is what you do in your homework and in your test. Sum of forces on Y.
0.
Sum forces on Y equals 0. This is CB equals 0. Move to sum of forces on X equals 0. CE 1994. Agree? So this is 1994 in this direction, means in here I have 1994. And this is 0. And this is tension. Let me show you something to make you understand way better. Here is a structure. It doesn't matter what is the shape. When we put the load in here and it's supported in here, what happens? Where goes the deflection? Like this, correct? So it has a belly here, correct? Agree? That is tension. Can you understand it's tension? Because it's stretching the muscles out of it. Because it's going to go. So what you do, you pull these fibers here away. But what is about the top side?
compression.
Compression, because you push them together. Okay. We'll move to
B.
A. B. B, joint B. Joint B, it has one line here that we know, 2230 here, and this one is going to be BD. Let's put this in this direction. And we have BE. I will put it this direction. I don't know which is the true. And BC. The BC, 0. Do I need to put it in here?
No.
It's easier not to put it so you can see the other elements. So this is 0. I don't need to draw it on the free body diagram. The only thing we need to know in here, this angle here, this angle, is it equal to alpha according to geometry? Can you see that? Everybody? So I don't need to waste my time according to the same height, the same width on both sides. So this is alpha. In this case, so this is alpha, this is alpha. Agree? Sum forces on x equals 0. 2, 2, 3, 0 cosine of alpha is positive. B, D cosine of alpha, which is 26.6, is negative. BE cosine of alpha as well, 26.6, is negative, equals 0. This is one equation with two unknowns, correct? Let's go to the second equation, sum of forces on y, equals 0. 2, 2, 3, 0, sine of 26.6 is hitting up that positive. BD sine of 26.6 heading down is negative. BE sine of 26.6 is positive.
Minus 400.
And we need to come here, and this is B, 400 and negative 400 equals 0. Two equations, two unknowns, plug them in your calculator and give me some answer here.
So for the direction of BD and BE, do
What's
we
that?
know for the direction of the BD and BE?
Just I put them
Oh, you
without
just-
thinking.
Okay.
We'll see,
We
we
don't
might
know
get
yet, right?
negative. We cannot tell.
Oh, okay.
Got BD of 1783 and BE of 447.
$1703,
1783.
178,
Yeah.
3, and BE
447.
and you get positive numbers. That means
I
that's
have the same.
They're both positive?
both positive, correct? We got both positive, means the arrows that we have indicated there are good. In this case, we come back here, we deal with B. BD is in this direction, means BD is in this direction. And BD 1783. The other one is BE is in this direction, means I have this here down here of 447. go further? Can we go further? We got stuck. If I come to this, I have a 3 unknowns. If I come to this, I have a 3 unknowns. So I need to scratch my head to find what other solution I can start now. The solution of H. Joint H. Joint H has these two members. Agree? HG,
That's 0,
HE.
0.
Sum of forces on X, HE is 0. Sum of forces on Y equals 0. HG equals 0. Agree? Everybody? In this case, I can go now to joint E. Joint E joint E, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Correct? Is that like this?
Yeah.
447 is this one. $19.94 is this one. This one here is 0. I don't need to show it. Correct? Get rid of it. This one is here, this one is here. I don't know. I'm not sure. So I just assign any direction. I will put them same direction. Good? Let's get them their names. E, D, and E, G. What about EG? This angle here
An alpha.
is alpha. Agree, is it alpha? Tangent negative 1 is 3 over 6. Or tangent negative 1 of 9 over 18. It's half, half. Correct? So, let's start. Sum of forces on X equals 0. 447 cosine of 26.6 is negative. EG cosine of 26.6 is positive. And negative 1994 equals 0. Agree on this? Anything else? Sum of forces on Y equals 0. 447 sine of 26.6 is positive. EB is positive. No, this is negative, sorry. EB is positive. EG sine of 26.6 is positive. Equals 0. Okay?
Is for f of x, is that negative? 447 cosine 26.6?
This is positive, positive, positive. Negative is this one, this is positive, this is positive. This is negative, this is positive, this is positive. Now it's correct. Plug them in your calculator, please, and give me some answer for
We got 1783 again
E,
for EG.
G, and E, D. 447 on X direction is positive, correct?
Okay, yeah.
On Y direction is negative because it's sitting down. Here is 447. On X direction is going to be this one. On Y direction is going to be this one.
ED is actually going down.
Give me the answer, the number.
Negative 999.
Negative.
Is that knowledge right?
That's what I got.
Negative 99.
Not 99. 999. For E. Oh, EG. I'm sorry.
This
EG.
one.
Yeah, that's 999. EG, I got 1783.
I don't think that's a 3.
17.
1783.
83.
Yes.
Okay, let's come here. Before we go back there, we need to fix it in here. ED, which is this one, is hitting down. So ED is hitting down in here. Because it's negative. Means ED hitting down here means it's hitting up here. ED 999.
Anybody else get ED of 598?
Actually,
Yeah.
it's what,
Yeah.
558.
You got 558.
598.
ED.
Yeah.
And
The 447 and EG are going in opposite directions there, so you can't have them together.
Right.
Yeah, I got that now.
Okay.
this one is here, means this one is here. Did you say this one is 1783?
Yes.
Again, do we need to keep putting compression, tension, or you are okay with 2 or 3 elements? Good enough?
We should change ED to 598. 999 is wrong.
999?
Yeah, it's 598.
598.
598. Here. 598. Okay. A, B, C, E, G, D now. Correct? Showing D. Joint D has this element here of 2. Joint D. 1783 is in this direction. Known. The 400 is here before we forget it. This element is DF. Same angle. 598 is vertical here. And DG. DG. I will put just this arrow in this direction and this arrow in this direction and see if we get positive or negative answers. The only thing we need to worry about now is to find this angle here. This angle, beta. Beta tangent -1 of what?
That's 9 minus 3 should be 6.
3 over 6.
Yeah, 3 over 6. Yeah.
It's alpha.
Maybe 6 over 6.
Is this 6 here?
Yeah, 9 minus 3. Yeah.
So this is
Oh, wait a minute.
It's gonna be 6
Yeah.
over 6.
Yeah, that's it.
6 minus 3.
No, it's not. It's not
This is a
6.
3.
I thought it was.
This is a 3.
It's alpha, guys.
And this is 6.
Yep. He's correct.
26.6. Same alpha. Read?
Yes.
Okay. So, again, sum of forces on X equals 0. 1783 cosine of alpha is positive. df cosine of alpha is negative. dg cosine of alpha is positive. Equals 0. Sum forces on y equals 0. 1783 sine of alpha is positive. df cosine sine of alpha is negative. dg sine of alpha is negative. Negative 400, positive 598 equals 0. Again, two equations with two unknowns. When you plug them in your calculator, you should give me df and dg. By the way, this question wasn't one of the midterms.
Take a while to solve.
3 hours to solve this.
1 hour.
Yeah, we have 2 other questions answered.
1 hour, 30 minutes for this. Come on, we will learn the techniques to make it faster. Any answer?
Yeah, give it a second to think. I've got, DF is 2004.
2004,
Yeah, and DG is 221. Anybody else?
221. DF is in this direction. This is here. DF, you said 2000?
2004.
2004. And this one, the other one is DG 221. 221. So this is continue to be compression, compression. This one here is compression. This one is compression. This one is tension. What is next? What is next? If I go to G, yes, this is 0, but I still have a 3. I go to F. Agree? Joint F. Joint F, it has 3 elements. 1, 2, 3. Has this force here with 400. $2,004 is this one here. I'm going to put this direction and this direction. Let's find the names. Fi and Fg. Two unknowns. Sum of forces on x equals 0. We have 2004 cosine of alpha is positive. Fi cosine of alpha is hitting this way, is negative, equals 0, or Fi equal to 004. Agree?
How do you know that it's 26.6 degrees?
This alpha here measured from horizontal, this one here, this angle here measured from the horizontal line equal this one. The same 9 from horizontal, the same 18. Everybody agrees on this statement, sum of forces on x. No break, I will give you to go home very early. No worries. For this patient, sum of forces on y equals 0. We have 2004 sine of the 26.6 is positive. Fi, which we said 2004 sine of the 26.6 is positive. Negative 400 and positive Fg equals 0. What is Fg? How much? I heard the 94,
1394.
13.
But I'm getting
Anybody else?
negative.
For FG,
Should be negative.
I got. Wait, one second.
Because it's 400 minus 4008 sine of 26.6.
2004 sine of 26.6 times 2 negative the 400. So this is, should be first negative answer to hit down. 1394?
Yeah.
1394 negative means this is hitting down, means Fg, this is down. Means this is up in here. And you said 1394?
Yes.
This one is hitting up this way, and we said it is 2004.
To go up to this far.
So, it's not going to help to solve more and more and more joints, correct?
You know, I do it.
So, did you get the idea how to isolate the joint, apply to equation of equilibrium? We need to move to the second topic. The second topic is called zero member. The zero member, basic zero member, 2 elements at a corner, like this one, each perpendicular on each other, if there is no external force, they are zero. That's the basic thing. The second thing is three elements. Join one joint. Okay? Two of them are on the same line. Two are on the same line. The third element come to join them. It doesn't matter at which angle. The third, if there is and the other condition, no external force at this joint. No external force. This is zero. It doesn't matter if it's like this, like this, like this, it doesn't matter. Now, don't look at this two as a straight line. These two are right in here. The third is this one. If there is no external force here, then this green is zero. Let's look at it like this. Two are straight, no external force, this is zero. Okay? Let's do example in here. We have this element here. This one is joining it like this. AB, AC, AD, or A here, AC, AB, AD, A here, AB, AC, AD. So it doesn't matter what shape, two of them are a straight line. Look, these two are on one line, these two are on one line, these two are on one line. The third come to visit, this one, third one. This one, third one, this one, third one, doesn't matter which angle. The third one, if there is here, at joint E, no external force, then AD is zero, AD is zero, AD is zero. Why is that? Look at this. Apply sum of forces on Y for this one. Anything applying on Y, the only one is this one. AD has component on Y. Sum of forces on Y on zero, then AD is zero. Here, sum of forces on X. This doesn't have any component on X, nothing on X. This is the only one, AD is zero. If you want to go through this, you will get a zero as well. Doesn't matter how much time you want to solve. When you deal with a structure that it has corners without external forces, again, remember, no external forces, then that element is zero. Okay, questions on this? Go select one problem from your book to identify the zero member. Yes?
Why are those parts there?
Why they are? Yes, it's a good question. We have been talking about the internal force.